Hi guys, would you be keen to take a practice test for DP-203 with me? Thought it would be something cool to do together. There are 50 questions here. We're given 2 hours, hopefully it doesn't take that long. And just like the real exam, we are given the 70% pass rate. Or 70%, we need to get 70% to pass. Yeah, so I've actually taken this test before, but I found it quite difficult. I think last time I took it, I got exactly 70%. So I thought it would be cool to go through it together and see how much I remember it from the first time. So this will be something fun. And if you're watching this at home, then feel free to do it with me, and let me know if you get it more than me or less than me or exactly the same as me. And yeah, so we'll take the test and then go over uh, all the questions that I get wrong at the end. So here we go. Begin test. Question 1. You have an Azure Synapse Analytics workspace named WS1. You have an Azure Data Lake Storage Gen 2 container that contains JSON formatted files in the following format. So we'll come back to this if we need to later. You need to use the serverless SQL pools in WS1 to read the files. How should you complete the transact SQL statement? Okay, so looking at here, so yeah, we haven't even looked at the JSON file, but open data source, open JSON, open query, open row set. I know that open row set is the only one with the bulk option, so I already know that should be an open row set there. And since we're dealing with JSON, that second blank there should be an open JSON. So the correct answer here should be open row set, open JSON. Next question. So in the question 1, we didn't even look at the JSON file. So I noticed that it does happen here and there with these questions. So when that happens, don't panic. That's quite natural. It actually saves you some time, so it's good. Question 2, you have an Apache Spark data frame named temperatures. A sample of the data is shown in the following table. Cool, you need to produce the following table by using a Spark SQL query. How should you complete the query? Okay, cool. One thing I do notice immediately is that we're going from like a long data type format to flatter data type format. So some sort of pivoting, I imagine. Select star from that, so that's the query there, and with the options there. So yep, so the pivot will be there. In fact, the first blank will be pivot, and when we compute the average, we're casting the temperature column as decimal column. So yeah, so the first is pivot and the second is cast. So pivot and cast. Question 3, the following code segment is used to create an Azure Databricks cluster. So yeah, here's the code segment. For each of the following statements, select yes if it's true, nah, otherwise no. So first statement says the Databricks cluster supports multiple concurrent users. So Databricks cluster mode that supports multiple concurrent users is high concurrency rather than standard or single node. So looking at this code segment, how do we know which cluster mode it's using? We look at the cluster.profile. So serverless is for high concurrency. So the answer for that is yes. And for standard, I'm pretty sure it's standard. And single node, I'm pretty sure it's single node. So as long as you don't see those, you can assume that you know that this is high concurrency. So that's good. The Databricks cluster minimizes costs when running scheduled jobs that execute notebooks. So for this one, we know that for that purpose, we don't want to use high concurrency, we want to use standard. So the answer is no. So far we have yes, no. The Databricks cluster supports the creation of a Delta Lake table. I think this is true for all the Databricks clusters, right? I don't know, maybe I'm wrong, but I always say yes to this. So yes, no, yes for me. Question 4. You are designing a statistical analysis solution that will use custom proprietary Python functions on near real-time data from Azure Event Hubs. You need to recommend which Azure service to use to perform the statistical analysis. The solution must minimize latency. What should you recommend? So performing like any kind of calculations, I feel like the Databricks is the one to go. And it integrates with Azure Event Hubs as well, so I will go with Databricks. Question 5. You have an enterprise data warehouse in Azure Synapse Analytics that contains a table named Fact Online Sales. The table contains data from start of 2009 to the end of 2012. You need to improve the performance of queries against Fact Online Sales by using table partitions. The solution must meet the following requirements. Create 4 partitions based on the order date. Ensure that each partition contains all the orders placed, I guess, using during given calendar year. How should you complete the T-SQL statement? So we have a create table statement here. And the options to choose from is to do with our partition, right? So it says here create 4 partitions based on the order date. If you want to create 4 partitions, then we want 3 elements in this value options there, because one would be before this date, one would be between these 2 dates, and then the second one, and the third one would be between these 2 dates, and the last one will be after the last specified date. So now the question is it range right or range left? I think do you guys know the difference? I didn't know it before, but range right and range left basically determines where the equal sign should be. Range left has the equal sign when it says smaller. Range right, it has the equal sign when it says it's bigger. Hopefully that made sense. Otherwise, please look it up. I think it's quite important. So this one here is looking at dates, right? So we're looking at from like end of the year to like from the whole year basically. So when we look at the first date, for example, 2010 0101, when we partition it, we want to partition by the dates that doesn't include but smaller. So that's what I mean by range right and range left. So if we don't want to include it, then it's right. Yes. So this one here. Question 6. You're designing an Azure Stream Analytics solution that will analyze Twitter data. You need to count the tweets in each 10-second window. The solution must ensure that each tweet is counted only once. You use a hopping window that uses a hop size of 10 seconds and a window size of 10 seconds. I was gonna say, every time I see each 10-second window, or I always think of tumbling window, and we can use hopping window, and the only time we can use hopping window is when the hop size is exactly the same as window size, which makes it a tumbling window essentially. So yes, this does meet the goal. And the exact same question here, and it says you use a hopping window that uses a hop size of 5 seconds and a window size of 10 seconds. Now we have different sizes for the hop and the window, which makes it not a tumbling window. So does this meet the goal? No. Question 8. You are building an Azure Stream Analytics job to identify how much time a user spends interacting with a feature on a web page. The job receives events based on user actions on the web page. Each row of data represents an event. Each event has a type of either start or end. You need to calculate the duration between start and end events. How should you complete the query? Okay, so we are given date add date diff or date part. So every time I see we need to compute the duration between some events, I always think of date diff, which computes the difference between two times. And we're given is first, last, or top one here. And if you look at it here, so if you think about what the second blank should be, I know that is first is outputs of boolean, so we can get rid of that. So it's last or top one, and top one is usually used in ranking things and then getting the top rank of that. So I'll go with the last there. So date diff and last. Question 9. Whew, a long one here. You're creating an Azure Data Factory data flow that will ingest data from a CSV file, cast columns to specified types of data, and insert the data into a table in an Azure Synapse Analytics dedicated SQL pool. The CSV file contains 3 columns named username, comment, and date. The data flow already contains the following: a source transformation, a derived column transformation to set the appropriate types of data, a sync transformation to land the data in the pool. You need to ensure that the data flow meets the following requirements. Of all valid rows must be written to the destination table. Truncation errors in the comment column must be avoided proactively. Any rows containing comment values that will cause truncation errors upon insert must be written to a file in blob storage. Which 2 actions should you perform? Each correct answer presents part of the solution. Okay. To the data flow, add a sync transformation to write the rows to a file in blob storage. To the data flow, add conditional split transformation to separate the rows that will cause truncation errors. To the data flow, add a filter transformation to filter out rows that will cause truncation errors. Add a select transformation to select only the rows that will cause truncation errors. Yeah, this is definitely one of those questions that I can't remember what the answer is to. So you need to ensure that the data flow meets the following requirements. All valid rows must be written to the destination. Truncation errors in the comment column must be avoided proactively. Any rows containing comment values that will cause truncation errors upon insert must be written to a file in blob storage. Okay. Maybe we add a select transformation to select only the rows that will cause truncation errors. Add a sync transformation to write the rows to a file in blob storage. So yeah, we select 2, right? Maybe we'd use conditional split, and then we don't really need to select, do we? If we're splitting it. I feel like this is what I did last time and I got it wrong. To the data flow, added filter transformation to filter out rows that will cause filter them out. No, we don't want to filter them out, right? Because we do still want to write them to a blob storage. To the data flow, add a sync transformation to write the rows to a file, and maybe add conditional split, and then we do that. We'll go with that for now. Question 10. You need to create an Azure Data Factory pipeline to process data for the following 3 departments at your company: e-commerce, retail, and wholesale. The solution must ensure that data can also be processed for the entire company. How should you complete the data factory data flow script? To answer, direct the appropriate values to the correct targets. Each value may be used once, more than once, or not at all. Okay, so yeah, so we're given here split. Okay, cool, cool. So I know that first of all we need to follow the order. So for example, if we put whatever we put in the first uh, blank has to match the order name of the order that we put it at the last blank. So here 3 departments, and so the order is not really given here, but I'm looking at these two options for the first blank. Is it either department e-commerce, retail, and wholesale, e-commerce, wholesale, and retail? So first thing is we do want all, right? We do want all, and that always gets added at the end. And if you look at the order here, e-commerce, retail, and wholesale, so that's gonna go in at the last blank. And if you follow this order here, then the second box, so the second box has to be the first blank, and the last box has to be the last blank. And what comes in the middle, it's disjoint true. So that's how we get the, because in here we say here that the solution must ensure that the data can also be processed for the entire company, and for that we want disjoint equals to true. So what that does is basically when we go through one by one, if we say disjoint equals to false, then the first matching condition is where the data is going in, whereas disjoint equals to true means all the matching condition the data is going in. So it's the correct answer here is this guy. Question 11. You have an Azure Data Lake Storage Gen 2 account that contains a JSON file for customers. The file contains 2 attributes named first name and last name. You need to copy the data from JSON file to an Azure Synapse Analytics table by using Azure Databricks. A new column must be created that concatenates the first name and last name values. You create the following components: a destination table in Azure Synapse Analytics, an Azure Blob Storage container, a service principal. Which 5 actions should you perform in sequence next in Databricks Notebook? Okay. So yeah, when I say read these questions out loud, I forget to read it in my brain. So let's see. You need to copy the data from the JSON file to an Azure Synapse Analytics table by using Azure Databricks. A new column must be created that concatenates. Okay. So the actions are mount the, so we want to choose 5 actions, right? And the available actions are mount the data lake storage onto DBFS or Databricks file storage. Yeah, so that would be the first step. Write the results to a table in Azure Synapse Analytics. Perform transformations on the file. Specify a temporary folder to stage the data. Write the results to data lake storage. So that will be the last step. Read the file into a data frame, drop the data frame, perform transformations on the data frame. Okay, so we've already got the first and the last stage, right? So first we want to mount the data lake storage onto DBFS. Cool. And then we want to read the file into a data frame. So what do we want to do again? You need to copy the data from JSON file to an Azure Synapse Analytics. Okay, so maybe that wasn't the what we thought wasn't the last step. So mount the data lake storage and read the file into a data frame and perform transformations on the data frame. And then you specify a temporary folder to stage the data, I think. So let's see here. So all the options start with mount the data lake onto DBFS. So and read, so we said read the file into a data frame. Draw the data frame wouldn't be it. Specify a temporary folder to stage the data. Wouldn't be it either, right? So I think it's this one here. Mount the data lake storage, read the file, so that's good. Perform transformation like we said. Specify a temporary folder. Write the results to a table in Azure Synapse Analytics. Cool. Yeah, that's what we said. Next question. Question 12. You build an Azure data lake. Question 12. You build an Azure data factory pipeline to move data from an Azure data lake storage Gen2 container to a database in an Azure Synapse Analytics dedicated SQL pool. Data in the container is stored in the following folder structure. The earliest folder is in here. The latest folder is in here. You need to configure a pipeline trigger to meet the following requirements. Existing data must be loaded. Data must be loaded every 30 minutes. Late arriving data of up to 2 minutes must be included in the load for the time at which data should have arrived. How should you configure the pipeline? Cool. So event pipeline, event trigger is when like there's an event and it's like a reaction to it. And that's not what we really want here. On-demand trigger is when we manually trigger, but we don't really, that's not really suitable here either. So it's either schedule or tumbling window. And there are some differences between those. And one of the differences is that tumbling window has the delay option, whereas schedule doesn't. So the type should be tumbling window. So, and yeah, so the next question kind of answers itself. And we want to set the recurrence and we want to set the delay as well. So the correct answer here is this guy here. Next question, question 13. You're designing a real-time dashboard solution that will visualize streaming data from remote sensors that connect to the internet. The streaming data must be aggregated to show the average value of each 10-second interval. The data will be discarded after being displayed in the dashboard. The solution will use Azure Stream Analytics and must meet the following requirements. Minimize latency from an Azure event hub to the dashboard, minimize the required storage, minimize development effort. What should you include in the solution? So this is like recognizing what each of the Azure services do, right? So Azure Stream Analytics input. So the answer here is input type, output type, and aggregation query location. Cool. So we are building a dashboard. So every time there's a dashboard, the best thing for that is Microsoft Power BI, right? So the output type, we set that as Microsoft Power BI. And input type, real-time dashboard, they will visualize streaming data. So real-time streaming, so we're looking at data constantly streaming in, so there will be Azure Stream Analytics. And aggregation query location. Oh, I see. So for this, I think data input is um, Event Hub maybe. Um, yeah, I'm struggling between those two. Yeah, so I think it's this. So I think the input type is Event Hub. That's the front. That's basically the front face. That's where the data is coming in and where you ingest data. So Azure Event Hub, and it goes output to Microsoft Power BI, and then the aggregation query location is Stream Analytics, where it takes care of the data streaming. So it's the first one. At least it's good to know that there's an option there. So looking promising. You have an Azure Stream Analytics job that is a Stream Analytics project solution in Microsoft Visual Studio. The job accepts data generated by IoT devices in the JSON format. You need to modify the job to accept data generated by the IoT services in the protobuf format. Which three actions should you perform from Visual Studio on sequence? Yeah, this is definitely one of the questions that I got wrong last time. And so here the actions are: change the event serialization format to protobuf in the input.json file or the job and reference the DLL. Add an Azure Stream Analytics custom deserializer project.net project to the solution. Add .NET deserializer code for protobuf to the custom deserialize project. Okay, add the .NET deserializer code for protobuf to the Stream Analytics project. Add an Azure Stream Analytics application project to the solution. So first thing to do is add an Azure Stream Analytics custom deserialize project to the solution. So the second box there. And then what we do is add the .NET deserializer code for protobuf to the custom deserializer project. Yes. So the second box and then the third box, and then the last one. The last one is change the event serialization. Yeah, so the last one is the first box. Change the event serialization format to protobuf in the JSON file of the job and reference the DLL. So this one here. Cool. Question 15. You have an Azure SQL database named Database1 and two Azure Event Hubs named Hub A and Hub B. The data consumed from each source is shown in the following table. Database 1, Hub A and Hub B. You need to implement Azure Stream Analytics to calculate the average fare per mile by driver. How should you configure the Stream Analytics input for each source? Okay, cool. So this is about recognizing the type of Stream Analytics input. So there's stream and reference, right? So this is like stream is the one that you expect it to change quite often, and reference is the one that you expect not to change often. So for example, looking at here, database 1, driver's name and driver's license number. Yeah, sure, the name can be changed, but it's gonna be quite rare. Ride route, ride distance, ride duration. So that's gonna be it will change more often. There will be new things coming in. There will be new ride route, new distance, and new duration. Same with Hub B data, ride fare and ride payment. So we're looking at Hub A. Hub A would be stream. Hub B would be stream. Database 1 would be reference. Question 16. You are building an Azure Analytics query that will receive input data from Azure IoT Hub and write the results to Azure Blob Storage. You need to calculate the difference in the number of readings per sensor per hour. How should you complete the query? Okay, cool. So the looking at the query there, select sensor ID, growth equals to reading minus one of those. So every time we want to calculate the difference in the number of readings per sensor per hour. So there's like a difference between numbers, right? So we want to look at so the most common thing here is lag. And so reading over partition by sensor ID, and we want to set the limit. And the most common, I mean, it is also most common, but it also makes sense to use the limit duration as well. So we're giving some sort of limit to the what window we're looking at. So it's lag and limit duration. Question 17. You are designing a monitoring solution for a fleet of 500 vehicles. Each vehicle has a GPS tracking device that sends data to an Azure Event Hub once per minute. You have a CSV file in an Azure Data Lake Storage Center container. The file maintains the expected geographical area in which vehicle should be. You need to ensure that when a GPS position is outside the expected area, a message is added to another event hub for processing within 30 seconds. The solution must minimize cost. What should you include in the solution? So we need to choose the service, window, and analysis type. Cool. So I think the analysis type is probably the most straightforward one here. So there's a GPS, and we have an area that if they go out of the area, we're flagging that. So for that, we use point within polygon. So pretty easy. And so service. So the service should be, because this is gonna be a GPS, so this is gonna be, the data is gonna be or near real-time streaming data, right? We need to keep track of that GPS position. So service would be Azure Stream Analytics. So window. So in terms of the window, so we see that you need to ensure that, so this is like when something happens, this needs to be flagged. So it's not like hopping, it's not session, it's not tumbling. I think it's no window. So stream, no window, and stream analytics, no window, point within polygon. Question 18. You are designing an Azure Databricks table. The table will ingest an average of 20 million streaming events per day. You need to persist the events in the table for use in incremental load pipeline jobs in Azure Databricks. The solution must minimize storage costs and incremental load times. What should you include in the solution? So we need to minimize storage costs and incremental load times, right? Yeah, no, I like I said, I've done these questions before, but I don't remember this question. So, partition by date time fields. I would go with that. Sync to Azure Queue Storage. No, that's not relevant. Include a watermark column. Don't think so. Use a JSON format to physical data storage. So yeah, I would say it's partition. Because I can see that I'm not 100% sure. I guess we'll see. Question 19. You have a self-hosted integration runtime in Azure Data Factory. The current status of the integration runtime is the following configurations. We can come back to this. Use the drop-down menus to select the answer choice that completes each statement based on the information presented. So if the XM node becomes unavailable or executed pipelines will cool. So the integration runtime has the following node details: name xnm, x-m, status running, and so on. Cool, it's self-hosted. X-m. So yeah, there is a where is it? Oh yeah, here it is. So you know how it says high availability enabled is false? So when that is false, um, when the node becomes unavailable, it will fail until the node comes back online. So we know the first answer to that. The number of concurrent jobs and the CPU usage indicate the concurrent jobs value should be. So this is to do with how much is available and how much is being used, right? So looking at concurrent jobs, 2 out of 14 is running. So there's a lot of wasted resources there. And CPU utilization, only 6%. So to save costs, right, the concurrent jobs value should be lowered. So the correct answer is this one. Question 20. You have an Azure Databricks workspace named Workspace 1 in the standard pricing tier. You need to configure Workspace 1 to support auto-scaling all-purpose clusters. The solution must meet the following requirements: automatically scale down workers when cluster is underutilized for 3 minutes, minimize the time it takes to scale the maximum number of workers, minimize costs. What should you do first? Let's see. Enable container services for Workspace 1. Upgrade Workspace 1 to the premium pricing tier. Set cluster mode to high concurrency. Create a cluster policy in Workspace 1. Yeah, I remember looking into this, and I think this question might be outdated. And I think it used to work that I don't know if it is still the case, but standard pricing tier didn't have the auto scaling, so you need the premium pricing tier for that. So we'll go that with the premium pricing tier option. So we've done 20 questions, guys. I think we'll stop it here. I will make a part 2 of this video, going through maybe 20 more questions, and part 3 like a shorter video of going through the last 10 questions. Yeah, hope you enjoyed it, and let me know if this kind of format is helpful for you. I thought it would be some fun to try something different. Yeah, hope you enjoyed it. But yeah, let's having said that, let's finish test and see what we got. Finish test. So review. I mean, don't worry about 38% because we've only gone through 20 questions. So, but we got 19 questions correct, and let's see what we got wrong. All questions, incorrect questions. So actually we only got one wrong. So looks like question 18, you're designing an Azure Databricks table. The table will ingest an average of 20 million streaming events per day. Okay, so it is synced to Azure Queue Storage. Ah, guys, like I feel like this is gonna be my excuse to all the questions that I get wrong. I don't know, but I tried to look this up, right, and I couldn't find it. So if we try to go to this link, it's not available. So I'm pretty sure this is an outdated question, and we don't have to worry about it. You know, this is a Udemy questions, and so we were gonna come through some of the questions like this. So it is what it is. But thank you guys for watching, and yeah, definitely gonna. It's a lot of fun doing this, so definitely gonna make a part 2 of this. Yeah, like I said, I hope this is useful. But thank you guys. We got this.